Good day and welcome to this video. This is the second part of the bonus class, and in this video we'll be treating string formatting. You've been taught one method of string formatting earlier in this training, but in this video we'll be dealing with two other methods. The method we are going to treat first is the str.format method. str.format. This method is what we are going to treat first. Let me just give an example of how it is used, then I'll start explaining. That's an example of how this method can be used for string formatting. What we have here, these braces here, the opening and closing brace, this is called a replacement field. That is the place where this value will be substituted into. So it's called a replacement field. And here is the syntax for a replacement field. Here, these are the braces. Here, so that's part of the syntax. The braces define the replacement field. There are three parts of a replacement field. You have the field name, you have the conversion, and then you have the format specification. So I'll only talk about this field name fully, and format spec I will talk about that partially. We'll talk about field name first. Talking about the field name, there are two forms in which the field name can be. The field name can either be numbers or keywords. The replacement fields are directly related to the arguments of this method format. Any function generally accepts two types of methods. You have positional arguments and keyword arguments. There are two forms of field names, like I said. You have numbered field names and you have keyword. I'll talk about field numbering first of all. That is using numbers for field names. Field numbering or numbered field names are directly related to the positional arguments of the .format method. I'll give an example now. There are two forms of field numbering. You have automatic field numbering and you have manual field numbering. Automatic is something like this. When the field name is not given, that is when automatic field numbering applies. That is, neither a number nor a keyword is given for that field name. How that works is each replacement field has an index. When we are talking about field numbering, every positional argument of the .format method has an index. This is 0, this is 1. If I keep on entering others and so on, that's 2, then this will be index 3, and so on and so on like that for the positional arguments. When it comes to replacement fields, they have indexes. That is, when automatic field numbering applies, the first replacement field has index 0, then this is given index 1 automatically. If I have another one here, this will be index 3, this will be index 4, and so on like that. Since there are only two arguments here, we just leave 2 here. You can see that works perfectly. That's for automatic field numbering. And one thing I should mention about automatic field numbering is that the number of replacement fields must not be more than the number of positional arguments. The number of positional arguments like this can be more than the number of replacement fields that are here. This will work correctly. But if I did something like this, there are 3 replacement fields here, but only 2 positional arguments. And there is no automatic field numbering. The method will automatically give this an index 0, index 1 for this one here, then index 2 for this. But when it checks the positional arguments you gave, this is only 0 and index 1. There's no index 2. So you see the error it will give now. Replacement index 2 out of range for positional arguments tuple. Just keep that in mind, that the number of positional arguments can be more than the number of replacement fields, but the opposite will lead to an error. That's for automatic field numbering. Now to manual field numbering. Manual field numbering is simply entering the field number manually like this. This you can use 0 and then 1. and it gives exactly the same results. You can number in any order. You can have 0 here and 1 here. So this 0 matches name and 1 matches age according to the index 0, 1, 2. So this will work. And then when you're using manual field numbering, you can have as many replacement fields as you want, but the numbers that you give those replacement fields that you put in the field name must not exceed the highest index of position arguments I have here. The highest here is 2, 0, 1, 2. Something like this can work perfectly. You can't have 3 here and expect it to work. Replacement index 3 out of range. Then one other thing I should mention about using numbers as field names or field numbering for automatic and manual is that you can't mix the two. You can't mix automatic field numbering with manual field numbering. Let me demonstrate that here now. If I try to delete this and delete this, maybe if you do not know that they can work together, you expect to do 0, 1, and then 2 will be here, and then 1 here again. But it will give you an error that cannot switch from automatic field numbering to manual field numbering. The same thing also occurs if you have automatic here, no field name, then you now put a field name here and here also. Let me change this to this. You can mix automatic field numbering and manual field numbering. Just remember that. The next type of field name, like I said, are keywords, using keywords as field names. I said the field numbering is directly related to positional arguments. Now, using keywords as field names is directly related to the keyword arguments. That is, arguments are given in this form. If you do let's say any m equals any argument given in this form is called a keyword argument. That is, the name equals, then you write the value there. So that is what is called a keyword argument. So you can have something like this. These NAM and AG here are keyword arguments. You can use the names of those keyword arguments as the field name in the replacement field. So I can have it like this. You can use them as many times in different replacement fields. You can use it like, okay, sorry, there's no name there. It's just NAM. You can see you can repeat them as many times as you want in different replacement fields. Then another thing about using keywords as field names is that you can mix it with automatic field numbering or manual field numbering. So if I do something like this here now, I must put positional arguments or else it will tell me index 0 or index 1 out of range. If I just have name here, note that this name is a positional argument and age here is a positional argument. These are positional arguments, these are keyword arguments. So now if I press enter, I can see everything worked just fine. This is index 0, which is this name. This is index 1, which is age. The value is 67 like we defined earlier. And then let's use this here and this here, sorry, here, and the last one here. You can mix it with automatic or with manual field numbering. If I put 1 and you have 0 here. But like I said, you can't mix automatic field numbering and manual field numbering. You can't expect something like this to work at all. You can't switch from manual to that. Keep it in mind. Let me give a few more examples before I move on to the next part. If I have a list that is details equals just a list, then name, then you have an age here. If I have this list and I want to use it with string formatting, I can do something like this. I'll put my list details. Now that details is given as a positional argument. I can then have 0. You have to use manual field numbering now, and then that's 0 represents details. But you know that the index of, normally you want to access this 80 inside details. You do something like details 1, and then that will give you 80. If you do details 0, that will give you dude here. So 0, this 0 is the index of details in positional arguments. You 0, and then as if you are indexing the list just normally, 0, 1, and this one will be 0, 0, 0, 0 right there, and it gives you exactly the same effect. The same thing for dictionaries. You can also use this if you want to do something like det equals details. This here is a keyword argument whose value is details, that is this list. So the name of the keyword argument is det. So I have det. You can't use field numbering or numbered field names for keyword arguments. Numbers relate directly to positional arguments, and keyword field names relate directly to keyword arguments. That's 1 and that's 0. That gives you the same effect. Then there's also, if you know, this has actually been used in some of the tutorials earlier on. When you are passing like this list now, if you want to pass these lists as the elements of these lists as separate positional arguments to this method format, you put the asterisk in front of it. It's called the unpacking operator. It unpacks the items inside an iterable. It can be a list, it can be a tuple, any iterable, anything that you can loop over. So you just put star in front of it and then details. So what that does is it unpacks dude and 80 as if you wrote dude here, as if you wrote dude and 80, exactly like that. That's the same thing it does. So you see the effect now. If I do this, you get this. If I do start details, you get exactly the same thing. That's one of the advantages of this method of formatting. You can just unpack an iterable there and then to match it to all of this. Just keep that in mind. Then using dictionaries, if I have a dictionary here, this dictionary is a positional argument as it is. 0 is the index of that positional argument, the dictionary. Normally, if you want to get dude, you do name like this as a string. But you see what will happen when I do that now. Invalid syntax. Because of the quotes, if I use a single quote, you still get an error. There's no, so it takes it as a string containing the quotes. You must take note of that. When you want to use dictionaries in formatting like this, you don't put the quotes. If the key is a string, you don't put the quotes. Just write it as it is. The same thing for this here. Not 0, just 0. Okay, this should be name, and then this should be age. You don't put the quotes if the key is a string. So you get exactly the same thing. There's another way of using dictionaries with the format method, and it's called the mapping unpacking operator, ***. You can see for iterables, for just sequences like list, sets, and other simple sequences, you just use star, a single star. But for a mapping, a dictionary, you use ***. And what that does is it unpacks the items of the dictionary as keyword arguments. Doing this now, you see the effects. If I do something like this, and then I have age here, and I have name here. Okay, key error. Sorry, should be double. Yeah, and that's what it does. So it unpacks these items of the dictionary. This operator, this *** unpacks the items of the dictionary as keyword arguments to this method format. It does exactly the same thing as this. This is exactly what it does. What this mapping unpacking operator does is to unpack these items as keyword arguments. It's just like name is name of that keyword argument, and then this is the value given to it. Age is the name of the second keyword argument, and then the value given to it is 78, just like the same thing that is here right now. Just keep that in mind. That's one of the uses of this .formats method, what makes very efficient and functional. The next thing I'll move on to is the format specification. Format spec, like we said earlier. Let me show it again. Okay, you can see format spec right there. This is what I want to talk about right now. This is the complete syntax of that format spec on its own. The colon is part of the syntax. That's what begins the format specification. And then after that, you have all these things in this particular order. That's why it's called a syntax. You must follow this syntax to use the format specification, or else you will get errors. So the ones in green are the ones I'll talk about fully. And then this type in blue, I only talk about it to quite an extent. The ones in black, I'll not discuss them in this video. Okay, so you should be able to see it now by the side here, and so that you can follow it as I'm explaining. The first part of the format specification I'm talking about is the type. So what that type is type representation. That is, this name is a string, age is an integer. So different types, especially strings and numbers, that is integers and floats for numbers, they have different representation types. For an integer, there are many representation types. I'll go through a few of them. Then for strings is mainly just S that you use. So just S:S now. I use :S. Let's use automatic field numbering. So you can use any form of field numbering with the format specification. The field name, the conversion, and the format specification, they are independent of each other. So you can use any one without the other, or use all of them together anyhow you want. It's not compulsory to specify the field name to use format specification. D is the most basic representation type for an integer. It's just the normal one like that. N is also another one. For strings is S. It's not compulsory. You can see even when we did not specify any format, any representation type, it just uses, when you don't specify, it uses the default representation type for that particular data type. If this is a float now, it has its own default representation type. So it just represents as it is like that. So for a float, you can use F. I use F now. That's one of representation types for floats. By default, you have 6 decimal places. I'll still go through how to change the number of decimal places later on. You have E, that's the exponential form. To also use 6 decimal places by default. You have other representation types, N and so on. There's also G. So I won't go through all of them. You can have many forms. So if you have percent here, if I have 0.3, that's 30%. You can see that percent it takes it 0.3 on a scale of 0 to 1. This is 30%. So that's exactly what it does. So those are different representation types for floats. For integers, you have a few more. If I have H here, you have quite a number of them. If I have X, that representation type shows the hexadecimal value of 67 is age is 67. So this is the hexadecimal for age for that 67. B is another one. B is for binary. Another one is O, that's for octal. This is the octal value of 67. Those are different representation types for integers, for floats. The next part of the format specification that I will talk about is the width. You can see width comes before type in the syntax. If I try to put type here now, B for binary, and then I put what width does, you see the effect. Or let me just use width without any type now, or use D, normal type. You see the effect of width now. You can see normally 67 will have just been like around this place, but it has changed from there to this now. What that width does is to increase it's called the field width of that particular value. It takes the original value and then pads it with spaces by default to make up that width that is specified, this 6. Normally this is just 2 characters. So it takes that 2 characters and adds spaces to it by default. It adds spaces to it to make up 6 characters, and then that's how it gets this wide form of this wide representation of the value. So you can also use it for tilde here, the name. If I put 20, you can see the difference now is wide, and then this, okay, I did not specify for this, for 60. So you can use the width with any representation type. You can use it with binary like that, because okay, the binary is actually okay. Yeah, that's one thing I should also mention. Let me first use a large one. If I use 20 with binary, you can use any representation format. One thing I should mention is the width does not override the original length or the original length of that value. If I use 3 here, 3 is longer than what this binary value is. This binary is that's 7 characters there, and I specified a width of 3. It doesn't mean that it will truncate that value to just 3 characters. It will just ignore that width. If the width is less than the original length of that value, it will just ignore the width and put the value as it is. So just keep that in mind. The same thing for any type, whether it is this 2 is 2, it will still put it like, it's not cut the value down to that number of characters. It's only when it is larger that the width applies. That's for width. You can use width for any type, like I said. If this is a float, and that thing is for if this value, because this value is an integer, it doesn't mean you can't use a float representation type. I can use F. Normally you can convert an integer to a float, so that's allowed. So you can use a float representation type. If this is a float and I use an integer representation type, you can see it does not allow you to use integer representation types for floats. If I use E now, and then this is an integer here, if I have an integer here, you can use float representation type for integers, but you can't use an integer representation type for floats. Next thing I'll talk about is align. You can see align there. Align is before width, and align works with width. What align does is to, let me put a width of 10 here. It's the binary value of age, and then this with 20, and then just the string like that. So you can see normally this is it. So what align does, you can see automatically this is a width of 10 now, and this here is a width of 20. The strings automatically are aligned to the left of that entire 20 characters. The original value will be aligned to the left, but for numbers, whether integers or floats, they'll be aligned to the right side of that width. And that's the default alignment for those types. If you want a different alignment, that's where you use align. But you can't use align without width. It doesn't make any sense at all to use align without width. It's when the width is larger than the original length of the value. That's when any alignment makes sense. So if I have this 20, and then there are 3 forms of alignment. You have left, right, and you have center. This character here is for left. This character, the right arrow, is for right alignment. This up here, this is called the caret. It's for center alignment. So I'll show them differently now. This left alignment is still the same as the default. If I use, let me use left for this here and use right for the name. You can see the difference now. This is the remaining space of that 10 characters. The numbers will align to the left. The same thing with this string has been aligned to the right, and then it has filled up the remaining space to the left. If I align both of them to the center, you will see the difference also. You can see you have some space here, you have some space here. The original value is in the center. Same thing with this one. There's one more form of alignment for numbers. It's just equal to. That's the character that is used for the alignment. It works with another part of the format specification that I will not talk about. That's why I decided not to talk about it here. The next thing I'll talk about after align is the fill character. You can see fill there. You can see it's inside the same square brackets with align here. You can see this is the square brackets for align, and then fill is inside it. What that means is without align, you cannot have fill. That is how the syntax is. If you put fill without align, this will end up in an error. I'll show you that now. Before you use fill, you must have align. Let me first show you what the fill is. You have alignments here. I said by default, format method fills the remaining characters with just space. And then you have these, you have spaces there. So if you want to use a different character, let's use something like if you want to have underscores there, you can see the difference now. It fills up that space with the character that you enter right there. If I have equal to, you have the same thing. But like I said, if you try to use fill character without alignment, you see invalid format specifier. So you must follow that syntax strictly. The fill character can be any character at all, any character. I can have a single character, it can't be multiple. You can see to give you an error now when you use multiple. It can be any character. If I use this, you can see it's filled up that space there, and then this with H. That's that for fill. Remember, you can't use fill without align. You can actually put align there without width. It won't give you an error, but it doesn't make any sense. And also, if the width is less than the original length of the value, it doesn't make any sense. Just remember that for fill or align to take any effect, you need to have a width that is larger than the length of the original value here. The next thing I'll talk about is precision. Earlier, you saw that when I use F and E, the float representation formats percent, all of them, you had 6 decimal places there. The precision is what's used to change number of decimal places for numbers. And then it also has an application to strings. I also show that. For numbers, this is age. You must have dots. That is syntax operation. Dot and then a number. It can be a single digit, it can be many numbers like that, but it's not allowed for integers. It does not make sense to use precision for integers because there's no decimal places. If you use the float type representation for an integer, it will work perfectly and convert that integer to a float and then use that value. You can see you have 667 decimal places there. So we give you whatever you put there, that's what to give you. You can have as many as you want. That's the default, which is 6. You can have 0. It will remove the decimal parts of it entirely. You can have 1 and so on. That's for numbers, whether integers or floats. But remember, to use the precision, you must have a float. If it's an integer, you must have a float representation type there. And then if it is a float like this, if you have 0.2, you don't need this type representation for that. Just use this. But for floats, the default representation type is defined, but if you don't understand it, you'll just be getting results that you don't want. So when you're using floats, it's best to just put the representation type that you want, whether it's F or it is E or it is G or anyone. So F for this, or it is percent, anyone you want, you specify it, and then you can have this. You can see with precision of .2, they have 2 decimal places. That's for numbers. When you are dealing with strings, the precision applies in a different way. You can see in the syntax, precision comes after with before type. If I put this here now, okay, no, that does a different thing actually. It takes everything as precision. The precision comes after the width. If I have 10 here and I have 20, I want to show you how precision applies to strings now. If I have .2, you can already see the effect. Let me remove that h, there is few characters so that you see it. You can see this is just du right there. It cuts that string. It's like slicing the string. If I have name, just like doing this exact :2, you have du. The value for the precision, if it's longer than the string, it doesn't matter. It will just stop wherever the string stops. You just have 4. Is the width 20. I gave the remaining space. The precision truncates a string as it slices the string, but precision for numbers controls number of decimal places. That's about precision, and that will come to the end of the .format method. The next method for formatting in Python that I want to teach in this video is called f-strings or formatted strings. Once you precede your string literal, that is the whatever you have in quotes like this, you precede it with f. That makes a formatted string. This has no replacement field in it, so it just gives you the string as it is. The special thing about f-strings is they can contain replacement fields. They don't need the .format method. It works on its own like that. So inside the replacement field, the syntax is exactly the same as for .format, the same replacement field syntax. You have field name, conversion, and format specification. Then the syntax of format specification is also the same thing. The only difference between the two of them is how you use field name. For field name, here you can't have numbering because there's no method that are giving position arguments to. All you have is using the names of variables that you've already defined. Name is a variable already defined. So once I do this, you have name, that, and then for age also, you have age. That's the name of the variable. So you can enter a number there also, and it will work just perfectly. You can also enter a string just like I've done here, and it will work just fine. But take note of the type of quotes that you use. If you use type of quotes, it will make this a whole string, and then here you have a syntax error. So just take note of the type of quotes that you use. That's the main thing. One thing I should mention for both .format and f-strings, if you want to actually use curly braces within your string, if you want something like this, you want your string to just be like this, for example. If you try to use f-strings and then you type name, the braces will no longer be there. When you want the braces to be part of the string, a double brace like this represents a single brace that is part of the string. You can see like that. It's not normally if you do a single brace to give you an error that you're expecting a closing brace, but a double brace represents a single brace that is part of the string. You can't have empty replacement fields in an f string like this. If you have this, it will give you an error. But when you use double on both sides, these double braces represents a single left brace. This double right brace here represents a single right brace in the final string. Okay, each of them represents one brace. When you want the brace to show in your string and you want something like this now, what you do is name, and then you have that double brace represents a single brace as part of the string. Now we have the replacement field itself and name, and then the closing brace that is part of the string, that double. You have exactly that. So the same thing applies to .format. If I have this, you get exactly the same thing there. If you can use it with manual field numbering, get the same thing. Also with using keywords as field names. If there are keyword arguments there, you get the same result. So remember, double brace for a single one that is part of the actual string. That is not a replacement field. If it's for replacement field, just a single brace. You can see this here, So it did not recognize this as a replacement field because these two make up these two here make up one brace that is part of the actual string. The same thing in this here. So there's actually no replacement field over here. Let me just show using f strings with the format specification. I have name, that's the variable name, and then you have colon 20, that's the width. You can have alignment and fill character also. The same syntax for format specification. If I have age here, I have 20, and I have dot 2f. You have something like that also. If I have percent for value, you can also have values here. Just have a value, maybe 0.5 now. I'll give you 50%. F strings can contain literals, like what you normally type as a float or an integer or something like that. You can even have a dictionary or list and co right in there. Okay, I think details is still there. Okay, let me just use that. You have f, then you can have details, and then you index it 0. That's due there. You can use it with format specification. Let me just give a final example to show why string formatting is important. If you have something like, say, something related to the projects that was given, if you have this dictionary stock, if you don't use string formatting, this is how you just print it. You just do for stock.items. You must remember this method that has been taught in previous classes, and then print. Normally, if you don't use string formatting, you will just print something like item, comma, price. So this will just give you everything like that. Imagine this name was one very long name, like bread sliced. We have something like this, and try to print this. You can see how everything is out of alignment now. This price is here, this one is here. If you add different lengths of names, everything will be scattered. This is the usefulness of string formatting. If you use string formatting in this situation, let's use f strings for example. So that's a string right there. So you can see the difference between this now and this. The difference is very clear. You can see how neatly formatted this second one is. You can have alignment to center. Anyhow you want it. That's the usefulness of string formatting. I hope you've learned something really good in this video, and please make sure you understand what is here because it will be used in the solution for the project you are given. There should be a demonstration video for the solution of the project, and also the code will be given. Thank you very much.